Well, that did. I guess probably it's good news it didn't erupt into a fight about QKD or PQC, right? That's an ongoing. That was the implication. Do you prefer math or physics, or both? I guess both is the answer. Anyway, moving right along, I want to introduce our next keynote, Dr. Elvira Shishenina. She's a Senior Director of Strategic Initiatives at Quantinuum. I assume you all know about Quantinuum, sort of a seminal player in this space. If you don't, I encourage you to connect with her and follow the company. She's going to give a talk titled Building the Full Stack for Key Maritime Applications, Fault-Tolerant, Quantum-Powered by Gen AI and HPC at the core. So join me in welcoming Elvira.
Maybe I will start with...
Is it?
Oh,
here it is. Voila.
Okay, thank you so much. It's a huge honor to be here today, and thank you so much for this amazing event and invitation. And I also wanted to heartfully congratulate Renewable and Abu Dhabi Ports Group and Maritime Academy for this amazing event. I know it will take a lot of courage to be at the forefront of innovation and emerging tech, and thanks for becoming such a great role model for the industry. Especially it's meaningful today because there was an announcement of a Nobel Prize in Physics yesterday, and it went to quantum again. So I think it's a good sign for all of us that we're moving in the right direction. And I'm very happy to speak today on the topic that probably one of my preferred is about the synergy between quantum and AI. If both technologies are actually powerful enough to enhance each other, and the most importantly, how it can affect or actually enhance the applications in the industry, and specifically the maritime industry. But before to start, I think the main goal today would be not only to give these visions about the applications, but also that we converge to the understanding their technology stays right now, because there is a lot of discussions where we are, where we're going to be. So I would like to start with a small example of a real case. This simulation here shows the example of one of the most critical reactions in energy transition called oxygen reduction reaction. This reaction is essential and is responsible for the performance of hydrogen fuel cell catalysts that are used in mobility industry, essentially automotive, aerospace, and maritime as well. A few decades ago, someone discovered in a very experimental way that platinum can be a very good catalyst to produce those fuel cells, but no one actually could uncover the mechanism of those reactions to say why it is so and what would be better, cheaper, and safer substitutes. So together with our partners from BMW Group and Airbus, we worked together since 2021 in order to apply best of quantum AI and classical HPC, and to try to uncover the mechanism of these reactions, and maybe to, at least at this stage, come up with a consensus and the IP and methodology and the tools that will be able to help us to find those better substitutes. The results of this collaboration, which lasts until now, was published recently in the Nature. We were able to demonstrate that we are able to capture strong static and dynamic correlations while representing this oxygen dissociation on the platinum cluster, as well as for the first time demonstrate some of the magnetic effects that propagate through the surface of catalysts, and not only capturing the dynamic on the surface. So this is something that we were incredibly proud of, and I'm also happy to spoil a little bit that we're preparing the partnership with BMW that will go beyond this already 5 years of collaborations towards bringing the first commercial value and the concrete roadmap that will leverage the next generations of our quantum computers to deliver this commercial value in early 2030. But stay tuned for that, and please follow the paper if you would like to learn more. And before telling you how we actually plan to reach there, probably it's nice to tell you where we're coming from. So Quantinuum was a result of the merger between Honeywell Quantum Solutions and Cambridge Quantum Computing, based in Cambridge. Since 2021, both companies are working together. We are so far the world's largest quantum computing company with more than 600 people employed all over the world and 6 countries representations, including US, UK, Germany, Japan, recently Singapore, and now Qatar as well. And hopefully we will be able to move here in UAE and work with you. Since 2021, there was a lot of engineering challenges that were solved. We do strongly believe in the roadmaps, the possibility to set the goals and actually deliver them consistently. And this is what we've been doing since the inception. So the world's first error correction was demonstrated on our H1 device. The world's first logical qubits, as well as end-to-end chemistry simulations on 12 of them, they're running earlier. And there is more to go. I will show you a little bit later. And this kind of constant achievement of those milestones gives us confidence to reach out to the fully fault-tolerant universal quantum computer already by the end of this decade with the capacities and enough of qubits to be able to handle the simulations beyond the achievable classic. But to not speculate much with the words, because, you know, universal fully fault-tolerant quantum computer sounds pretty fancy. Maybe to bring a little bit more definitions what it actually does mean. Universal means that it performs any quantum mechanic operations or properties beyond classical ones. For technicians here, maybe on the mathematical language, means that we need to be able to apply both Clifford, which are easily accessible by the linear algebra, and non-Clifford gates that are a little bit more tricky, complex, and computationally costly to achieve on the quantum computers. Fully fault-tolerant means that we need to be able to correct the errors at a certain level of confidence and during the certain period of time of simulations that will enable us basically the highest accuracy results in the end. And fully fault tolerance means that we actually have to be able to correct them all, so all the possible sources of errors. And all these 3 points are the essential and must-have ingredients in order to achieve those holy grail exponential advantages that won't be absorbed by the cost of deployments in the industry. And this is what we are aiming for. All right, so I'll be honest, this slide I picked from our CEO's presentation during the World Quantum Summit. And actually I have this thing which I also picked from our hardware team. I will let you to touch it later, but basically this is the list of the world's records in order to achieve the points that I mentioned on the previous slide that were achieved on this device, H2, current generation of our quantum computers, during the last year. It's a little bit of technical, but basically this is all about the fidelity, about the leave of logical qubits, and also about the capacity to perform the simulations that are not only, let's say, not only large enough in terms of size, but also quality enough to give us credible results. And probably the last metrics that I think the entire quantum community is grateful to IBM, our colleagues here present, is quantum volume. We invented that. And this probably speaks the most to the last point I mentioned. Recently, we achieved a new record in quantum volume, which is 33 million. It's a number but to give you an order of magnitude, the second biggest quantum volume in commercially available devices is 2000. So we're constantly improving this metric, and obviously there are a lot more to go, but this is something probably that can speak about the milestones and goals set up towards to achieve the value in the future. And about the value, so this is our current generation quantum computer, but there's a lot more to go. In the next month, we will be announcing our new generation quantum computer, Helios, which will be the first in the world having the 50 logical qubits, which will enable us to bring some of the very meaningful insights to the most prominent applications. I'm not speaking about advantage yet. It's a very tricky question. I think that whoever will speak you about advantage today, and especially in the areas like chemistry, optimization, etc., will most likely mislead. The only products in quantum and advantages available right now are based on probably the quantum random number generators. This is what we are able to execute. For the applications in materials research, logistics, etc., it will take a few more years to go, but it's not to be discouraged. It's actually to prepare the foundations to develop those algorithmic primitives in order to transform them in a fully functional software to be run on the machines that are capable to deliver this commercial value. So I'm very heartfully inviting you to follow on this launch announcement, and whoever will be in the United States, please ping me. I will be able to invite you. Yeah, she's coming. I hope without your wheelchair this time. Yeah. And of course, this powerful hardware has to power also not less powerful software and middleware stack. This is how it looks like at Quantinuum. We are relying on our quantum systems. We are also welcoming the quantum systems coming from the other quantum computing companies, including IBM, including IKM, Pascal, and others. We are having the very functional development environment, Nexus, as well as compiler ticket that we took a strategic decision to make an open source. This compiler not only enable you to basically code in agnostic way your applications, but also smoothly and in the most optimal way translate them to most of the commercially available systems and languages. Again, IBM, IKM, some of the ion trap devices, etc. So that's how we want to contribute to community and show that future probably will be multi-channel, meaning that there will be many technologies that will make it in the different applications, and we of course want to be a part of the success in the future. And last but not least, we're building the software stack together with our software teams. A cybersecurity topic was mentioned today and will be mentioned more and more. We have our quantum random number generator-based tool for encryption called Quantum Origin. This is also software, so it's basically delivered as a seed that you can integrate smoothly within your products and actual pipelines, and you don't need to have a cost of the entire quantum machine. As well as it was one of the first, or probably the first actually, who got the NIST certification, meaning that it can be now employed by the at least US government, and we're looking forward to progress with the certifications later. Quantum chemistry, I gave example earlier, and I can speak infinitely. It's probably one of the most preferred areas, as well as one of the most native to get the quantum advantage. And last but not least is quantum and AI. Okay, I accelerate. So there is a lot of discussions or probably it's not even a secret that modern AI can help a lot to quantum, starting with designing the computers themselves, designing better circuits, designing better correction and algorithms. And this is basically what we were trying to prove together with Google's DeepMind while working on applying their alpha tensor to optimization on the circuit and reducing the amount of those tricky non-Clifford gates, Toffoli gates. Of course, the collaboration was successful. It was recently published as well. Well, there is a Nature link right now as well. But we reduced or optimized the circuits to 37%, and it was great. But I think the most fun result out of that collaboration, at least for me, is that Through those experiments, the alpha tensor was able to identify some very hidden patterns in the circuit and rediscover the circuit optimization mechanism that was previously discovered by the scientists, but it took them years to come to that. And this shows how powerful classical AI can be in order to design better computers and algorithms. On the other hand side, there is a lot of discussion about the modern power of modern generative AI, and it progresses dramatically. But the only thing that classical generative AI is struggling with is actually representing the nature and representing the quantum physics. And this is the quantum can actually enhance. So I very much like this analogy where we compare quantum computing with a sort of microscope that provides you access to the classically inaccessible data, or we call it quantum data. Either it's a ground state energies of molecular systems or some complex encryption parameters. Then you feed this data to the classical generative AI, and you might expect better predictions, better speed to solutions, as well as probably better energy efficiency, which is now is quite important because we hear examples of nuclear plants being used to run the most advanced AI models. So this is what we are right now working on. We have classical AI team established within Quantinuum, and we're trying to implement basically those ideas to life together with our partners through different industrial verticals. It's energy, oil and gas, food security, finance, healthcare, biology, biomedicine, as well as cybersecurity. And this is very important because someone already mentioned today it takes a village to raise the child, and this is exactly what it means. It not only involves the expertise in quantum hardware, software, and compilation and error correction, it also involves the subject matter expertise, as well it involves the expertise in or knowledges of the workflows and pipelines of the current industrial processes, which is very important because you don't want to find yourself out with a perfect solution that you have no clue how to integrate within the processes. So it's important to take into account from the very beginning in order to succeed and to be the first one to succeed. And the cool thing about the previous slide is that all those solutions, they are still built on mathematical primitives that are pretty much transferable. So we can practically take those methodologies or core tools and replicate them or transfer them into the maritime industry and maritime sector and build the new solutions. Again, cybersecurity, I won't speak about it more because it was already extensively uncovered today. Materials for corrosion inhibition, energy and durability, against the aging, which is very important and probably one of the most native use cases for quantum. Logistics optimization, this is something that will take a time still to come, but we are on a good path, and I'm sure my colleagues from Pascal and IBM, they will speak about that later today, and Kipu, of course, as well. And last but not least, everything related to the topological data analysis or time series applications with transformers. This is something that we still need to discover, and we need to start right now. So concluding, it's basically up to us how to shape what's the next coming, and thank you so much for your kind attention.